Welcome students. Now let us continue the CET questions on thermodynamics. Now right now I am in adiabatic process related questions. Now it's question number 41. The work done in adiabatic change in a gas depends only on. Let me write the expression for work done in an adiabatic process. It is given by nR by gamma minus 1 into T2 minus T1. Okay, if you look at the equation, there is a change in temperature T2 minus T1 on which the work done depends. So that's why it has to be option C, the correct answer. 42. Which of the following process is the entropy change 0? First of all, students, entropy change or entropy is actually a measure of disorderness, we say. Measure of disorderness. And entropy change is given by the equation delta S equals delta Q divided by T. See, if the molecules are in disordered state, we say there is an entropy. And delta S is the symbol used for finding the change in entropy. It is given by delta Q by delta T. But in adiabatic process, we all know that delta Q is equal to 0. If delta Q is 0, then I can easily write that change in entropy is also 0, which means in the adiabatic process only the entropy change will become 0. It's option C. 43. A monoatomic gas of gamma equals 5 by 3 suddenly compressed to 1 by 8 of its original volume adiabatically, then pressure of the gas will change too. Students, we have an expression for adiabatic gas in case of pressure and volume, that is PV power gamma equals a constant. Then I can write P1 V1 power gamma is equal to P2 V2 power gamma. Okay, I need to find out the final pressure. Then I can write P2 is equal to V1 divided by V2 whole power gamma multiplied by P1. Now, let me substitute V1 here. If you look at the statement, it is 1/8 of the original volume. That means here the final volume will becomes 1 by 8 of original volume. Then I can substitute V2 as 1 by 8 times V1 whole power gamma, and gamma is 5 by 3 multiplied by P1. Now what happens to V1 and V1 here? It get cancelled. Now 1 over 1 by 8. It is going to be 1 over 1 by 8. The whole power 5 by 3 multiplied by P1. And 1 over 1 by 8 is 8 power 5 by 3 multiplied by P1. Then 8 can be expressed as 2 cube whole power 5 by 3 multiplied by P1. So 3 and 3 get cancelled. It is 2 power 5 into P1, and 2 power 5 is 32 P1. This is going to be the final pressure. That means the final pressure is going to be 32 times the initial pressure, which is option D. Please look into the steps. Go to the steps one by one. Watch the same question repeatedly. You will understand how the mathematics are involved here. Next, an ideal gas at 27 degrees Celsius is compressed. That means the initial temperature T1 is 300 Kelvin. It is compressed adiabatically to 8 by 27 of its original volume. So V2 is going to be 8 by 27 times of V1. And if gamma is equal to 5 by 3, then the rise in temperature is T2 minus T1. We have to find out. But to determine T2 minus T1, I should find out T2 first. So I have an adiabatic process equation in terms of temperature and volume. T into V power gamma minus 1 equals a constant. Students, even in the theory also I have written this expression. TV power gamma minus 1 is a constant for an adiabatic process. Then I can write T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1. So I want T2 here. So T2 is equal to V1 by V2 whole power gamma minus 1 multiplied by T1. Now V1 I will write as it is. V2 is 8 by 27 times V1 whole power gamma, that is 5 by 3 minus 1 multiplied by 300. Next, V1 and V1 get cancelled. Now T2 is equal to 1 over 8 by 27 whole power 5 by 3 minus 1 is 2 by 3 multiplied by 300. Now this 1 over 8 by 27 will become 8 by 27 whole power 2 by 3 multiplied by 300. Students, 27 is 3 cube, 8 is 2 cube. So I can write it as 3 by 2 whole power 3. This is whole power 2 by 3. We can write like this. Because 27 by 8 is 3 by 2 cube. 3 cube is 27, 2 cube is 8. So I can write 3 by 2 whole cube, whole power 2 by 3. Now this power 3 and 3 get cancelled. This 3 in 100 is already there. That's the temperature. Now what is left? It is 3 by 2 whole square multiplied by 300, which becomes 9 by 4 times of 300. Okay. Now T2 is going to become 475 times it will go 300. Now what do you get T2? It is 9 into 75, and 9 into 75 is 675 Kelvin. This is the final temperature, students. But the question is not about the final temperature, because the initial temperature is 300. Okay, the final temperature is 675. I need the change in temperature. Okay, what is the change in temperature? T2 minus T1 is the change in temperature. It is 675 minus 300, and the change in temperature would be 375 Kelvin, option B. If you look into the mathematical steps, you will understand, students, the powers 2 cube, 3 cube, you should have that idea. And then simplification leads to the final temperature. And after finding the final temperature, take the difference in temperature. That is the rise. Next, 45. Which of the two, number 1, compressing a gas isothermally until its volume reduced by half, compressing the same gas adiabatically until its volume reduced by half, will require more work done? So in the first case, you are compressing gas isothermally. That means without changing temperature, volume get reduced to half. In the second case, you are compressing the same gas adiabatically. There also volume get reduced to half. In which case the work done is going to be more. So work will be done, or more work is done in the case of adiabatic process. That is option 2. So whenever you compress gas adiabatically, the work done is going to be very high. That's very important. It's option B. 46. Pressure temperature relationship for an ideal gas undergoing adiabatic change is its P power 1 minus gamma T power gamma equals a constant, which is option D. Students, there are 3 equations for adiabatic process. One is PV power gamma equals a constant. Another one, TV power gamma minus 1 equals a constant. And this is the third one, that is option D. So the first one is between P and V. The second one is between T and V. The third one is between P and T. Next, for a gas of non-rigid diatomic molecules, the value of gamma is, non-rigid diatomic gas molecules, the value of gamma is 7 by 5. Okay, for a diatomic gas molecules, gamma is 7 by 5, because for a monoatomic it is 5 by 3, for a diatomic it is 7 by 5, for a triatomic it is 9 by 7. So diatomic it is 7 by 5, option B. If gamma denotes the ratio of the specific heat capacities of a gas, the ratio of the slopes of adiabatic and isothermal curves at the point of intersection will be. Students, let me show one thing here. If I plot a graph of pressure versus volume, see, this is going to be pressure, this is going to be volume. The isothermal curve is like this. With increase in pressure, volume decreases. But an adiabatic curve is a steep curve like this. So this is adiabatic curve and this is isothermal curve. If you look at the change, isothermal curve is like an exponential one, but adiabatic curve is a sudden decrease. It's a steep curve which shows there is a sudden decrease in volume or sudden increase in volume, whatever. Now this is going to be the point of intersection. The question is, if you take the slope of these curves at their point of intersection, what will be the ratio of the slopes? It's exactly gamma. It's exactly gamma. Slope is nothing but delta P divided by delta P. This is the slope. It's found to be gamma if you take the ratio of slopes for adiabatic and isothermal. 49. When a gas expands adiabatically, what happens? No energy is required. Energy is required and it comes from the wall of the container. Internal energy of the gas is used to doing work. Law of conservation of energy, does not holds good. Students, it is actually option C. See, generally what happens in the case of adiabatic process, no heat is supplied and no heat is given out. There is no heat enters the system, there is no heat leaves the system. And when the gas expands adiabatically, the amount of internal energy there, it is going to increase or it is going to decrease during the adiabatic process. Whatever the changes of the internal energy is there, it will be utilized to do work. You know how? Let me tell you. According to the first law of thermodynamics, delta Q is equal to delta U plus delta W. And in adiabatic process, delta Q is 0. So as a result, delta U plus delta W will become 0. Then delta U is equal to minus delta W. That means work done is completely dependent on the internal energy, which is going to be option C in adiabatic process, because in adiabatic process, no heat enters the system, no heat leaves the system. Next, 50. In changing the state of a gas adiabatically from an equilibrium state A to another equilibrium state B, the amount of work equal to 22.3 joule is done on a system. That means you are changing the state of a gas adiabatically. From A to B, the work done is 22.3 joule. If the gas is taken from state A to state B via a process in which the net heat absorbed is 9.35 calorie, then the net work done in the second case is. The question is, you are changing the state of a gas from A to B, that to adiabatically. What work you are spending do for that process? You are spending a work of 22.3 joule. That is in the first case. But if the same gas is taken from A to B in another process where heat absorbed is 9.35 calorie, then what is the work done in that case is going to be? Students, first of all, we should know one thing, that in adiabatic process, delta Q is equal to 0. Right? Let me use the first case. In adiabatic process, let me use the first case. In adiabatic process, the second case they have not mentioned what is that process. Okay. In adiabatic process, delta Q is equal to 0. As a result, delta W is equal to delta U. Okay. Now, what do you get delta U here? The work done is 22.3. So, delta U is going to be 22.3 joule. Remember this one. And in the second case, students, it's not about the adiabatic one. So what we do in the second process, this is the first process. In the second process, I have an equation delta Q is equal to delta U plus delta W. It's not an adiabatic process because look at the statement, heat is absorbed. In adiabatic process, no heat absorbed, no heat is given. In the second process, heat is absorbed. So it cannot be adiabatic process. Okay. Now work done I have to find out here. Then work done is going to be delta Q minus delta U. Whereas in the first process itself, I have obtained what is delta U, because delta W and delta U are equal in first case, that is adiabatic process. Now delta Q is 9.35 minus delta U is 22.3. It's 9.35 into 4.2 joule, because calorie ಇದೆ, joules convert ಮಾಡಬೇಕು, minus 22.3. So this is the work done in the second case. 9.35 times 4.2 ಅಂದರೆ ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ಇಟ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ ಲೈಕ್ 40 ರೇಂಜ್ ಬರುತ್ತೆ ಅಥವಾ 39 ಬರುತ್ತೆ. ಇಟ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ 39 ಸಮಥಿಂಗ್ minus 22.3 ಬರುತ್ತೆ. If you take the difference, the work done is going to be around 17 joule, almost 17 joule, which is going to be option B. Students, let me repeat. In question number 50, in the first case, a state is changed from, the state of a gas is changed from A to B, and it's an adiabatic process. Work done is 22.3. But if the same gas is taken from A to B in another process, heat will be absorbed. That is 9.35 calorie. What is the work done in the second case? Then what I do, first case I will take in adiabatic process, delta Q is 0 because no heat is absorbed. Then delta W and delta U are equal in adiabatic process, which is 22.3, so that I got to know the delta U value in the first case. In the second case, definitely it's not adiabatic because there is heat absorbed. Delta U plus delta W. Then delta W becomes delta Q minus delta U. What is delta Q? 9.35 calorie. What is delta U? 22.3. But you know 1 calorie is equal to 4.2 joule. Substitute that as 4.2. 9.35 into 4.2 minus 22.3. So the product of 9.35 into 4.2 will give 39. 39 minus 22.3 is 17 joule. Very closest option is 16.9 joule. Next, an adiabatic process occurs at constant heat, because you know in adiabatic process delta Q is 0 and Q is going to be a constant, and Q is constant means option C. For adiabatic process, gamma is Cp by Cv. So which of the following option is correct? It's option C. It is Tv power gamma minus 1 equals a constant. In an adiabatic expansion of a gas, initial and final temperatures are T1 and T2 respectively. The change in internal energy of the gas is. Students, in adiabatic process, delta Q is equal to delta U plus delta W. This is based on first law. Correct. Now, we know delta Q is 0 for adiabatic process. Then I can write delta U is equal to minus delta W. That means if you want to find out the change in energy, it is minus of work done. So minus of work done means, so work done formula in the case of adiabatic process is R divided by gamma minus 1 into T2 minus T1. Okay, but here the change in internal energy is a negative of work done. Negative of work done means it is minus R by gamma minus 1. For the same equation, put minus into T2 minus T1. But minus of R by gamma minus 1 is also equal to R by gamma minus 1. Instead of T2 minus T1, I would be taking it as T1 minus T2. So this becomes the change in internal energy, which is option B. The work of 146 kilojoule is performed in order to compress 1 kilo of a gas, 1 kilo of a gas adiabatically, and in this process, the temperature of the gas increases by 7 degree, then the gas is. Okay. Now students, it's an adiabatic process. Then remember delta Q is equal to 0. That is very important for us. Then delta U and delta W both are equal here. Correct. If delta U is equal to delta W in adiabatic process, then I know delta U is equal to N into Cv delta T. This is the formula for delta U. Okay. If you calculate delta U, then that itself is work done. Delta U is delta W, students, but delta U is NCV delta T. So I can write that if both are equal, then I can write that work done is equal to N into CV delta T. But as I already shown in the previous cases, CV is expressed as R divided by gamma minus 1. Okay, let me substitute that one. Delta W is equal to N into R by gamma minus 1 into change in temperature. Okay, then I want gamma minus 1, students. Gamma minus 1 is equal to NR delta T by work done. Okay, now what is the number of moles? 1 kilo. 1 kilo is 10 cube. R, it is 8.3. Change in temperature, it is 7. The whole thing is divided by 146 kilojoule. It is 146 into 10 power 3. Okay, now 10 power 3, 10 power 3 get cancelled. Okay, 8.3 into 7. So 8 sevens are 56, 3 sevens are 21. It is 58 by 146. Now gamma minus 1 is 58 by 146. It's almost 0.4, almost. That leads to gamma value as 1.4. Students, remember, gamma is 1.4 means it has to be a diatomic gas. It has to be diatomic gas. I'll tell you one more thing. There is a direct formula here also. Because in adiabatic process, I have a work done formula, that is NR divided by gamma minus 1 into T2 minus T1. This is also a standard formula which is derived in the case of work done in adiabatic process. You can even use it directly. But just I wanted to show, even in this method also you get the same formula. That's why I used this expression. So it's option D. That's the work done in the case of adiabatic process. Next, 55. When heat given to a gas, when heat is given to a gas in an isobaric process, the work is done by the gas, internal energy of the gas will change, both A and B, none from A and B. Definitely both are going to happen, because the only process where nothing is going to remain constant is isobaric. Nothing is going to change. is means nothing is going to vanish is isobaric, because if I write the first law of thermodynamics, delta Q is equal to delta U plus delta W. Delta Q is 0 in adiabatic process. Delta U is 0 in isothermal process. Delta W is 0 in isochoric process. In isobaric process, nothing is going to be 0. That's why in the delta Q is equal to, that is in isobaric process, it is going to be delta U plus P delta V. This is going to happen. So it is option C, both A and B. That's option C for question number 55.